Well, hello everyone. Hope you're doing great today on this awesome, incredible Friday. Today we have two of our favorite things, systems of equations and word problems. I know you can't contain yourself. The excitement is unbelievable. I do have a warm-up for you, so as always, go ahead, pause this, and you can feel free to work this out. This is elimination. Nothing... it looks like I need to multiply not one of my equations, but both of my equations by a number of my choosing so that I can get matching coefficients so that I can then eliminate and solve this system. So go ahead, pause this, and solve away. When you come back, everything will be there. All right, go for it. Hello, welcome back. Just like magic, everything has appeared. Fantastic. Answer 5, -2, and hopefully you can see what you did right. If you did something wrong, hopefully you see where you went wrong. Again, I didn't have to necessarily multiply by 7 and -3. I could have multiplied by -7 and -3, or -7 and +3. So not my only option there as far as that goes. But let's dive into today's notes. Looks like there's some smiley face homework for us at the end of this. Lots and lots of word problems, guys, 20 of them to be exact. So at any point in time, if you're feeling like you can do these, you just go right ahead, pause this, and have at it. In the meantime, we're going to start right here. Here are your kind of steps to do these. Step 1, define your variables. Step 2, once I get those defined, now I can set up my equations. I can write them. Then I can solve them, and then finally we can identify our answer. So we'll start out with some basic ones, and we'll work up to more challenging, complicated ones. It's going to take all of our brain power today on this Friday. The sum of two numbers is 30. Their difference is 12. Again, you can say the first number I'm going to call x. The second number I'm going to call y. The sum of these two numbers, well, sum means add, x plus y is 30. Their difference is 12. Okay, their difference means subtract. Difference is 12. Find the two numbers. Today we can solve by any method you see fit. So if you're a substitution person, go for it. If you're an elimination person, go for it. Heck, you want to graph it? I don't care. Graph it. Okay. If I see this, I'm going to say, you know what? Let's eliminate. I see the same coefficients in the x's. I see opposites in my y's. I would rather add than subtract. So I'm going to say, hey, x plus x, 2x. Y plus negative y cancels away. That should turn into 42. Very quickly, we divide. And let's see, our answer should turn out to be 21. Halfway done. Pick either equation, plug back in, x plus y equals 30. Again, I know x is now 21. We can easily figure out what y is. So find the two numbers. The numbers are 21 and 9. Well, that wasn't so bad, Mr. Friggy. Jeez. Okay. Let's just move right down the road here. Number 3. Okay. The difference between two numbers is 9. The first number plus twice the other number is 27. Again, find the two numbers. So, hey, first number x, second number y. Difference between the two numbers is 9. I believe I could write that as x minus y equals 9. First number plus twice the other number is 27. So the first number, if I add that to twice the second number, is 27. Again, solve however you'd like. I would like to use elimination, and I would like to subtract because I see the same coefficients here in my x's. X minus x is 0. Negative 1y minus 2. Negative 3y. 9 minus 27 turns into, I don't know, negative 18. that's not right, just yell at me. Divide by -3, I get y is equal to 6. Choose either equation. Let's just say x minus y equals 9. So now it's x minus 6 equals 9. And we can solve this equation. Voila. Add 6 to both sides. So again, what are the two numbers? Make sure you answer the question. 15 and 6. Right? Those are our two numbers. Sum of two numbers is 20. Difference between 3 times the first and twice the second is 40. Find the two numbers. So again, first, second, the sum of the two numbers is 20. Okay, that's not anything crazy. X plus y equals 20. Difference between, so we're going to subtract these two things. 3 times the first, so 3 times the first, I know I'm going to be subtracting, there's your difference, and twice the second is 40. Okay, solve it however you'd like. Just to be different, I'll go substitution, guys. I'm going to solve top equation for x and say x equals 20 minus y. And let's plug this expression in everywhere I see an x right here. So 3 times 20 minus y minus 2y equals 40. A little bit of distributive property here. And good. Let's say, hey, all this combines to -5y. Need to move 60 to the right-hand side. It's a positive 60, so we're going to subtract 60. So this turns into -20, and y turns out to be +4. Okay. X plus y equals 20. So in other words, x plus 4 equals 20, or x has to be 16. So again, find the two numbers, 16 and 4. Okay, so why don't we do this? 2, 4, 6. Guys, pause this. Give those a quick shot before we get into our second kind of problems, which deal with money and that sort of thing. So 2, 4, 6. Have at it. Go. Hello, welcome back. Okay, here are our 3, 2, 4, and 6. Here's the 3 problems I wanted you to do. Here's your answers for those. All right, let's move on to number 7. So number 7, I would say more typical of a systems problem than the other ones, but the other ones just remind us how to write expressions that we now turn into equations that we now solve. Here's what I know. The cost of 3 boxes of envelopes, 4 boxes of notebook paper is this much money, $13.25. However, 2 boxes of envelopes and 6 boxes of notebook paper cost this much. Find the cost of each. So again, define your variables. We've got envelopes and notebook paper. So if you guys just bear with me, I'm going to say E is envelopes and N is notebook paper. So here I had 3 envelopes and I had 4 boxes of paper, and those were equal to $13.25. This is where all of our work that we did the other week will help us, right, for this right here. Second equation, 2 boxes of envelopes, all right, plus 6 boxes of notebook paper. Apparently I changed. I lied to you guys. I'm really using the variable P. Are 17. All right, what do you want to do here? How do you want to solve it? What would you like to do? Makes no difference to me. I would say, let's just use substitution. No, let's not do that, because that's not going to be a great idea. Let's go elimination. Again, substitution will work. We're going to end up with some not great numbers, but at the end, everything will work out just fine. So I'm going to multiply this equation by 2, multiply this equation by 3, and here's what we're going to get. So this turns into 6e plus 8p, and this is equal to 2650. All right, multiplying the second equation by 3, 6e. All right, now I've got 18. And gosh, what is that, 51, I think? Okay, same coefficients in my e variable means subtract. So my e's go away. 8 minus 18, negative 10. 2650. All right, minus 51, negative 2450. Makes me happy because for a second I was beginning to think we were going to have a negative number. Okay, notebook paper is 245. So there's one of my answers. Go ahead and let's slide over a little bit. Pick either equation. 2e 6p equals 17. Again, everywhere I see a p, I'm going to plug in 245. So 2e plus 6 times 245 turns out to be 1470. All right, we're going to subtract that from 17. Turns out to be $2.30. Divide by 2. E is $1.15. Go. So find the cost of each. So envelopes are $1.15. Notebook paper, $2.45. So this was paper, and this is envelopes. Great. Onward we go. Number 8. My good old favorite, oranges and apples. Here we go. 12 oranges and 7 apples cost us $5.36. 8 oranges, 5 apples cost us $3.68. Find the cost of each. Okay, so process is still the same. 12 oranges plus 7 apples is $5.36. Over here, 8 oranges and 5 apples, $3.68. Okay. Again, I think substitution is a little bit more challenging because we get some bad numbers. But in an effort to prove to you that it really does work, we can do this here. So pick an equation, and then let's solve it. I'll choose to solve this equation for A. So 5A equals 368 minus 80. And then I'll probably use some decimals here, guys, so don't be alarmed. Because, again, we're going to have to work with them sooner or later. So 368, if I divide that by 5, again, 368 divided by 5 is 0.736. It's a great number. 8 divided by 5, just 8/5, or 1 3/5. That's just 1.60. All right, so this is not a great equation, but we can certainly use it. Everywhere I see an A, we will now plug that into this equation. All right, so again, this is 12O plus 7 times the quantity. Here we go, 0.736 minus 1.60 equals 536. Distributive property. Here we go. I've got 12O Let's see, 0.736 times 7 is another great number, 5.152. All right, then we're going to have 1.6 times 7. That's going to give me negative 11.2 equals 5.36. Okay, so I need to combine. Be careful. This is a variable here. I need to combine my variables. There they are, 12O minus 11.20. That gives me 0.80. O is not a great variable to use because it looks like a 0. 5.152 needs to go to the other side. It will subtract. All right, so we're going to have 5.36 minus 5.152. This turns into 0.208. All right, we're getting closer. Now we just need to divide by this 0.8, and we get O, which remember are oranges, turn out to be 0.26. Again, we're talking cost here, 26 cents for an orange. I think that sounds good. So oranges are 26 cents. Need to figure out apples. Again, go back to either equation, as I definitely run out of room here. Apples, let's use again, it makes no difference. Let's use 8 oranges plus 5 apples being equal to 368. 368. And I know oranges are now 26 cents a piece, so I can multiply that by 8. So my oranges cost me 208 in this scenario. All right, we can subtract 368 minus 208 to figure out that, hey, 5 apples cost you $1.60. Well, what did one of them cost? So divide by 5. Apples were 32 cents. All right. And there's our answers. I guess it all depends. If apples were 32 cents, which one I would buy. Probably stick with oranges, though. Woo, okay, there you go. So again, substitution works just like elimination, all in what you prefer. Why don't you give 9 and 10, 11, 12. Why don't we just do the rest? Why don't we go 9 through 12 here, guys? Go 9 through 12. Again, define your variables, write your equations. Don't believe there to be any bear traps in 9 through 12. All right, so pause this, right? Solve those. If you're getting the hang of these, you don't need to solve them all. But if you're struggling with these, you need to solve them all. All right, you know how you're doing. So if you're doing great, solve a few of these. All right, great, move on. All right, so anyway, pause this, do 9 through 12. Okay, welcome back. So here's your answers for those 4 problems. Again, maybe 11, as I look at it, might have been a bit of a hiccup. But, it goes back to what we did the other week. If we have money, we need to make an equation about money. Smaller mowers, larger mowers, right, equals this much. If we've got one that just tells me about how many mowers in total that we sold, smaller ones plus the larger ones have to equal how many total ones I sold. So again, that might have been a little bit of a hiccup if we forgot that. But all in all, I think we should be okay there. Again, if you're struggling, you maybe need to go on and give the rest of these a shot. I don't think we need to do all 20 of these. I think we can get the hang of this after 4, 5, 6, or 7. Just depends on how much we need. But again, I'm going to pause this. Do whatever you need to on 13 through 17. Solve however you want to solve. If you want to use the graphing calculator, come up with your equations, put them in graphing form and graph them, that's fine. Right? We can do that. If you'd like to use substitution or elimination, it's all good. So anyway, give this a quick pause, and I'll throw some answers on here for you. Work through what you need to. All right? End of the day, here's what we got going on, right? We've got these lovely 10 problems here. I would like you to pick the odds. Okay, so let's put that on here. So homework is odds. Woo! Thanks, Mr. Freaky. You're awesome for not making us do all 10 of them. But you certainly can if you'd like to. Okay, so do the odds. Again, if you need some more practice, I'm going to put the answers, all right, over here on 13 through 20. So pause this, come back in a second, and they'll be here. All right? Have an awesome Friday, guys. Hello. Welcome back. Here you go. So here's our solutions, 13 through 20. Might be a good idea just to write down these in case, you're having some difficulty and we're running short on class time or whatnot. Write these down so that way you can practice a little bit more at home over the weekend. Again, it's just writing it correctly, solving it however you'd like. Okay, so hope this was good. Again, don't forget homework odds, right? That's good old homework number 6. All right, homework number 6, the odds. Let's give that a try. Have a great day, everybody.